that are members of our joint undertaking. Today, we're going to spend a little bit of time giving you an update on where we are on the AI factories, and give you another update on how to apply for time on our supercomputer, on our systems. And then I'm really, really delighted that we have three case studies from different AI factories, and one actual real life use case to explain to you what these factories will be for, what the antennas will do, and how you all can have access to our systems. So without further ado, I just want to show you one picture, which to give you an idea of how far across Europe our factories have now gone. If I go to the next slide. So as you can see, we have a combination of AI factories and AI antennas, which will in the next few months will be up and running, and will be able to provide you with the AI services that you will need, so that you can then take advantage of the compute power that the European Union has invested in here in Europe. So that's a bit of a picture of where we are at the moment. I'm going to let my colleagues talk you through that in a bit more detail in a second. So without further ado, I see we have 153 participants. I'm going to get going, and I'm going to pass the floor to my colleague Vangelis, who will tell you a little bit more about this project that we're working on, and how you can take advantage and benefit from it. Thank you.
Okay, thank you, Joe, and good morning all. Nice to see so many people joining in this morning. So I'm sharing my slides, and there you go. So since this is an update, I kind of assume that many of the people joining today have seen the previous one in May. So the focus will be mostly on talking about updates. However, I would do a quick walkthrough of all the aspects of EuroHPC and the AI Factories program in order, to bring everyone up to speed in case you have missed the previous time. So I will start with a very quick introduction about EuroHPC, who we are. We are a European Union body established in 2018. We are based in Luxembourg. We have, as a European Union body, we have a main stakeholder, the European Commission, who is holding, let's say, 50% of our shares in the governing board. But also the rest of the governance is supported by 37 participating states, with a recent addition of Moldova just last week. All the states that you see on the map, which are essentially the 27 EU member states, along with a number of associated countries. Our mission has been established by our regulation in 2010 and has been amended twice, has been refreshed twice. Initially, we started as a pure supercomputing initiative, focusing on high-performance computing, with a purpose to develop supercomputing infrastructure in Europe, which should be hyper-connected and federated. And also, we are funding research and innovation programs on supercomputing. This mandate has been updated at the beginning to introduce quantum computing, and then later artificial intelligence systems and AI factories. During the past years, we have been developing a large infrastructure of supercomputers across Europe. Probably you have seen this picture in the past. I will walk you through very quickly where we are right now and what we are offering in terms of systems. First, we started with programs for acquiring and putting into operation petascale and pre-exascale systems. And this first phase has been completed, and we have 8 systems now operational coming out from these procurements. beta scale systems like Deucalion, Meluxina, Vega, Carolina Discover, and pre-exascale systems, which are biggest systems right now we are operating, Mare Nostrum 5, Leonardo, and Lumi. Moving from this first phase, the second focus was on exascale and mid-range systems, so systems with higher capabilities and performance, reaching a exaflop performance. Out of this program, we have Jupiter, which is our first exascale system installed in Germany, in Jülich Supercomputing Center. This has been recently inaugurated in the beginning of September. The system is on the floor, is in a pre-production phase. Already some applications have got access, mostly for as first comers and for testing the system and stability. The system is being stabilized right now, and we really anticipate to be in full production in a couple of weeks. Then the second system, part of the exascale, Lys Recoq, that is will be installed in France, operated by Gency and SEA. This one is in procurement phase right now. We are concluding the evaluation of the tenders that have been submitted. Our plan is to announce the winning bid in next month in supercomputing in the US, in St. Louis, and also we will give you more details about the architecture. This is, so again, it will be a system aiming for exaflop performance. And then as part of the mid-range program, a number of systems are already have been contracted and are under installation. These are the Arrhenius in Sweden and Daedalus in Greece. And we are working on 2 more procurements for the Caspir system in Ireland and the Levende system in Hungary that should be launched by the end of this year, beginning of next. There's one more smaller system, the Innovative UC in Italy. This will be an industry-oriented system, which is co-funded with local companies in Italy. If we put all these numbers together, what we offer right now, it's 8 systems, as I mentioned, but what comprise 21 partitions, essentially. Overall, the total performance in petaflops is almost 1 exaflop, 900 petaflop. Soon to be reaching 2 exaflops with the addition of Jupiter, Daedalus, and Arrhenius. And in terms of sizing, CPUs, GPUs, and especially GPUs that is of particular interest for the AI applications. Right now, as you can see, we offer around 30,000 GPUs of various architecture, NVIDIA A100H, 100H, 200, as well as AMD MI250X. And this number is expected to almost double pretty soon with the addition of Jupiter, Daedalus, and Arrhenius partitions. This will be NVIDIA GH200. Only just from Jupiter, we expect around 24,000 GPUs to add it in the pool, really significantly reinforcing the capacity of our infrastructure in this aspect. In terms of budget, we are reaching 1.3 billion of funding of the systems, without including here the AI Factories program. And of course, to these systems, we have supported thousands of applications so far, allocating millions of node hours among the applications and users in Europe. Moving to factories, I presume that the concept of AI factories is known to the audience. Very quickly, the official definition that the Commission has given is that AI factories are dynamic ecosystems that build around an AI optimized supercomputer, offering data capacities, programming and training facilities, and including human capital that is aiming to support the development of AI industry and research in Europe. It's aiming to cover strategic sectors, industrial sectors, taking advantage of AI in Europe, including, for example, health, life science, manufacturing, climate, space, etc. And these systems are the largest ones, are expected to offer around 25,000 GPUs, AI accelerators for AI applications. Total investment around 10 billion euros for the period of 21-27. This not only for infrastructure, but also additional aspects of the AI factories. So again, if we want to visualize a bit, the center of these AI factories are the supercomputers that we are procuring, that they are going to offer resources to AI workloads. But around it, it's the human aspect, is the talent, development, is the access to data, is the enabling of national policies and boosting the national AI policies around domains relevant to specific countries. They aim to play the role of one-stop shop, is where you will go as an AI application, as a company, as an SME, to ask for support, to request resources, to be trained how you can use these AI resources to train your own data. So you saw already the list of the AI factories that we have selected. Joe stole my thunder there. However, already in May, we announced that out of 2 cutoffs for the call of expression of interest, we have selected 13 sites to host AI factories. Just last week, we announced the selection of 6 more AI factories, and probably this will be the last ones of the program. So the last batch is the second AI factory in Poland, in Krakow, the GEA AI, Spain, the One Health AI. This is it will be located in Galicia, and then for AI factories in Romania, Czechia, Lithuania, and Netherlands. Some of these AI factories are consortia of additional countries, so it's not just 19
Vangelis,
states. Yes?
Vangelis, sorry, just to say, I think your slides are blocked. Is there any way you can... We're still on the exascale slide, the first slide, the ecosystem slide. Sorry to interrupt.
So in my side...
No. Okay, it's the system then.
From my side, I'm already in the slide.
I know, that's what I thought, because I could hear you saying it. So, okay, everybody, we will make sure the slides are available. Keep talking, Vangelis. And maybe...
Shall I try to reshare maybe?
Why not? Why not? Yes, please. So, as usual, Teams is not always optimal, as you can all imagine. Dear colleagues. Is everybody got any? Can anybody see a different picture from the supercomputing ecosystem that I can see?
I'm afraid no.
Okay, thank you.
No problem.
Okay, while we're doing this, I'm just going to give you a little bit of housekeeping. This webinar is recorded, just so you're aware. And the chat is turned off, but you can ask Q&As via the Q&A button, which I'm told is at the top of your screens. So if you do have questions, please don't hesitate to ask them as we go on throughout the the morning, and we will endeavour to answer them as and when we receive them. Or alternatively, you can save up your question for the Q&A session at the end. Okay, so we're now in Vangelis, how are you doing? Okay, Teams is failing us completely and utterly. Okay, never mind. I'm going to go to your slides, Vangelis, and you can present from, I'll try and present for you. Apologies for this. Teams is failing us miserably. Yeah, I can see.
Someone just had a good recommendation that we share the slides on the chat on the Q&A.
Yeah.
So I will see if I can post it.
And I will present them in the meantime, so we can keep going. Sorry about this, guys, but one thing we can't control sometimes, as you'll know, is technology. Okay, here are the slides. Can you see them? Someone let me know.
We can see the slides now.
Okay, thanks.
I'm back, by the way, and
You're back. Shall I present for you?
yes, you can go to the slide with AI factories.
This one?
Yep. Yeah, not next one. I mean, I presented this one and the concepts. Yep. Okay. And I was here. No, the previous one. Previous.
Okay.
Yep. Here.
Sorry. Yeah.
Okay.
Okay. Go ahead.
So, sorry. So these are the all the AI factories we have selected so far. With blue is the new additions just joined. So as I was saying, it's not just these countries. There are additional countries behind it. There are consortia that have been brought together in order to co-fund the systems and also collaborate on the services to be offered by these factories. Next slide. And then there is the concept of AI factory antennas. So the idea of this call and of this program was that some countries that wanted to participate as part of the AI factory collaborations that I mentioned before didn't have the opportunity while the selection process of the AI factories was taking place. So we want to give this opportunity, especially for additional associated countries to the European Union, in order to join the consortia, to work together with established AI factories on the various areas that these factories were aiming for, in order to support then locally the countries and generally reinforce Europe on this aspect. So a call for a grant, number of grants was launched in the summer and were evaluated beginning of September, and last week also they were adopted the final list of AI factories by the governing board. Next slide, please. And we have selected 13 sites to act as AI factories. So as you can see, we're covering now areas like Iceland, Hungary, Ireland, Cyprus, Latvia, Moldova, Switzerland, Slovakia, Malta, Belgium, North Macedonia, United Kingdom, and Serbia. So these countries behind it, there will be collaborations with a number of AI factories. But as I said, the idea is that they will be providing now, they will be offering this access to their national communities, but also participating in the overall ecosystem that has been established in Europe of AI factories. Next slide. So these pictures, I tried, it's come from the commission, it tries to put together all the AI factories along with the antennas, showing you the coverage of Europe from all these selected sites. And also I have put it inside the list of systems that they are available. So what's important for people that really want to access these systems and to run applications. Obviously, so far, we have not been able to put into operation any of these systems, the new systems. However, there was already from the call for expression of interest the possibility to reuse established supercomputers with AI capabilities with GPUs in order to kickstart the process, to kickstart the offering, to give the possibilities for the first AI applications to run through the AI Factories program. So, for example, in the Jupiter, Alice, Recoke, and Daedalus have been designated as it's such kind of systems, although, of course, as I said, only Jupiter now is being prepared to go full production. However, for the other existing systems, Mare Nostrum 5 is offered from the AI factory in BSC. Leonardo and the recent upcoming upgrade of with the Lisa will be offered by Itzneka as part of the Italia factory. Lumi is offered as part of the Lumi AI factory, and we have Lumi AI currently in procurement in a competitive dialogue. System is expected to come by the end of next year. Meluxina is offered by Lux Provide, the AI factory in Luxembourg. And we have the upgrade, the Meluxina AI system, the final stages of tendering. Also, we are aiming to be one of the first systems to go online. From the AI factory in Bulgaria, right now, the Discoverer supercomputer with the upgrade of Discoverer Plus, which contains GPU partition, is offered as part of the AI factory, and we are preparing to launch a call for an AI-oriented system. In Slovenia, Vega is offered. Vega has a small GPU partition and now is used by the local AI factory. And we are preparing a procurement for the Vega AI system now that considerably is going to boost capabilities there. We have two more systems under procurement, the Hammer High and the Mimer, Germany and Sweden, which also will be one of the first to come online next year. And all the other systems that have been introduced recently, and of course in the past week, but also from the second cutoff, are now under preparation. We will plan the procurements to be launched by some of them by the end of the year, most of them middle of 2026, and many systems from this cutoff will be coming online then in 2027. Next slide. So moving to the question now, how we get access to these systems. My colleague Laura will present the mechanisms, but in brief, we have established for many years now access calls to our systems, various ways for applications to get access through either a peer review process or very fast track access for smaller applications. And the important here for the AI applications is that there is a specific AI pillar with the various different calls, some smaller, some more heavyweight that require peer review, that they're aiming to give access, first of all, very quickly to applications to test and kickstart their process, but also to support also some bigger, more demanding applications, like, for example, as you will see in the large-scale access call. The website where you can apply is the link here in the middle. But as I said, Laura will provide more info in the next presentation. Next slide, please. And the thing is that, as I said, AI Factory is not just systems, it's just also services. when you are applying to a system, you are applying for compute resources. But in order to find out and to get support from the AI services point of view, you need to contact at the moment directly the AI factories. And for this, you should go to our website. There is a specific section that has been designed listing all the AI factories right now available, the countries, and most importantly, next slide, maybe for you the domains, the industry domains that these AI factories are being designed and are being developed to support, having the necessary skills and know-how. And my recommendations for those who are interested is that you check what is your area of application, what are the AI factories offering support in these areas, and get in touch with them. And through there, if a requirement of using resources becomes evident, becomes a necessity, then you will be able to apply through our AI access calls, or in some cases, if you are locally in the country where the AI factory is active, you may get access from the national time. This is how the AI factory resources and services are offered. Maybe this will be optimized, be combined in the future, but at the moment, this is the approach you should use in order to get access to these AI factory facilities. And with this, I conclude my presentation. Sorry for the glitches, but really from our side, I don't know what went wrong.
Vangelis, absolutely no problem. That's why we're a team and that's why we work together. So no problem at all. I think everybody got the slides in the end. So thank you very, very much for that. And I just wanted to add a small parenthesis. The AI Factories portal will be updated to include the new AI factories and the new antennas that were agreed upon last week. So that's work in progress. So just a little bit of advertising. Keep going back to the website because it's a work in progress and it will be updated imminently. On that note, I would like to introduce Laura as our next speaker. She will tell you a little bit more about how to access the infrastructure that has been provided. Laura, over to you. You have the floor. Thanks a lot.
Thank you, Joe. I hope the technology cooperates. Can you hear me and see the slides well?
All good. So far, so
Okay.
good. But don't worry,
Okay.
we're there if something goes wrong, we're there. No problem.
Okay. So good morning, everyone. My name is Laura Martinez Calvo. I recently joined the peer review sector here in the EuroHPC JU. For the ones that don't know us yet, we are in charge of managing the access calls for the EuroHPC JU systems. The idea with my presentation is to give you a brief overview of the calls, specifically about AI optimized systems that are available right now. Vangelis was mentioning that some systems will be available in the future, but I'm centering my presentation on the calls and on the partitions and systems that you can access today. So basically, we are going to talk a little bit about the access modes for AI factories, the eligibility criteria. Also, depending on which profile of applicant you are, which call will be the most recommended from our view, that we cover your needs better. Also, taking into consideration your technical needs. After that, I will talk a little bit about the process, about advice on what to do and what not to do when applying, and just practical information about the calls that have been gone so far and the upcoming dates. So the big question, as you can see, and Vangelis also mentioned earlier, we have like a lot of calls. So from the applicant point of view, it could be difficult to choose, okay, which one is better for me and for my needs. So basically, at the present time, we have two different access modes. I'm centering on industry too. So we have one specifically and exclusively for industrial applicants. That means that the applicant has a vinculation with some industrial organization, SME, startup. And then we have one in which not only industry, but also scientists, public sector users, and academia can also apply. So in the first one, in the first access mode, only for industry, we have three calls: playground, fast lane, and large scale. And on the other access mode, for science and collaborative EU projects, we have another call that I will describe now. But first of all, the formal aspects. We are a public entity, so this is important. I'm insisting on this because if you're not complying with these rules, unfortunately, we cannot give you access in these calls, okay? So be aware that the organization of the project leader, PI, team members should be either from Horizon 2020, from Horizon Europe, or the Digital Europe program. I've linked the list of countries so you can check which countries I'm talking about. Also, the project lead and principal investigator has to be employed by this organization throughout all the duration of the allocation and at least after 3 months of the end of the allocation. Okay, and there are some rules of participation that the SMEs have to be compliant. Everything that I'm talking is on the terms and of reference of each call. You can see the documentation of each call, so don't worry if it's too much information right now, okay? So coming back to the applicant, we are talking about industry. We will consider also the level of skill. Let's say if you are a beginner or if you are an experienced user, maybe you have already participated in one of our calls, or you know the partition in which you are going to work. Also, the resources that you require. We are talking about GPU hours. Maybe you just need like a limited resources just to try some things, or maybe you have really huge needs. We're talking about millions of GPU hours. This is also covered with the calls that I am presenting now. So in this case, we will have here like the 4 calls. Entry level, limited amount of resources, access up to 3 months will be playground, a little bit more of resources, fast lane, and for big projects, we will have either large scale and AI for science. You can see the maximum duration of allocation. So we have a range of resources and a range of duration of the projects. So choose which one is best for you, for your needs. And one thing that is especially interesting about the innovation for industry access mode only industry calls is the time to resources. It goes to up to 10 working days. For the AI for science and collaborative projects, this time is a little bit longer, 1 month. But as you can see, the cutoffs, the frequency in which you can apply is almost continuous. So we think that this facilitates a lot the preparation of applications. Another note, especially for the beginnings, for the entry-level users, the AI factories, as Vangelis mentioned, includes human people and includes human support, okay? But apart from that, the EuroHPC JU is also linked to 3 different initiatives that could also help you, okay? The Centers of Excellence in Supercomputing, they are very topic related. So let's say they are like a group of experts within a field, a research field. For example, there are centers of excellence about climate, about astrophysics. So there you can find people who actually know about your topic. They usually develop software or pipelines that are very useful and tools in that specific topic. So it's worth mentioning. The Minerva project, which is giving support of any level to the users, starting from how to port your code into a supercomputing center, or to optimize your model, or help you with the pre-trainings in artificial intelligence. So also check it out. And finally, the EuroHPC is a network of national competence centers in these related technologies. So in your country, you have like a group of people, like a team, who is dedicated to be updated of whatever that is happening in the country about HPC, AI, big data, even quantum. So basically, all these initiatives, they provide training and they provide support for free. So check it out because they can help you. Okay, and now in a more technical aspect about the applications, we are currently working with 6 systems. The infrastructure is a little bit different depending on your needs. You can have like NVIDIA, AMD, etc. And you can see that all of them, the 6, are currently available for the playground call, and some of them for the other 3 calls. We have like a fixed range of resources in the playground, Fastlane, and AI for Science calls, but the largest scale, you can see that we go to up 50,000 GPU hours until like 29 million. So here's talking the peer review office too. Please be aware of the range of resources that you are asking for. You have to justify the need for those. Be aware of the partition that you want to apply. Be aware of their ranges to see that there are slightly differences between them. And here I added also the link of the AI factories. You can check this with all the time that you want. Any question, you can contact us, of course, but honestly, everything is online. So about the peer review process, we try to make it quite a straightforward, simple, and fast. Okay, so we are working with an online platform, and this is common for all the calls I'm talking about in general. I will specify certain details later, but as any application of any project, we want to know what you want to do. We want to know your team, and we want to know about ethics. AI, you know, the AI Act is here, and we have to be compliant with that. I also mentioned in the first slide that the application should comply with all of this, so have that in mind. Regarding the calls that provide the more amount of resources, we also add into the application a specific section for collaboration and funding and the dissemination strategy. Okay. The portal is really user friendly. It's nothing that requires like a tutorial. So just to give you a little bit of more detail in these 2 bigger resources calls, we have an evaluation about it. So there will be like the criteria for the largest scale will be centered into innovation and impact. This is a call only for industry, so we are focused on getting things done. So innovation and impact of the project. For the AI for Science, as this is in the intermediate zone with science, we also consider the excellence and the quality and efficiency of the implementation. Okay. So you will have to describe a little bit based on this criteria of evaluation in your application. And the process is quite straightforward. As I said, in all of them, we do a first eligibility check. We check that everybody complies with the rules that I presented in the second slide, that everything is in place, all the forms are filled in, the documentation is provided, etc. After that, there is a technical assessment. This is done by the hosting entities, by the supercomputing centers that have the partitions that you are applying to actually check the feasibility of your project. Okay. And in case of the larger scale and the AI for science, the projects are bigger, we have industry innovation group evaluation in case of the industry only larger scale call. And we have 2 experts that will review the AI for science applications. They will provide a consolidated report of evaluation, and if these steps are all good, you start your project. Okay. Our role here and our interactions don't finish here. Okay. There is like a post-project action that we have to do, and this you need to provide a final report. We want to know how things went. Is your opportunity also to give us feedback on how things were done, what were your results, etc. And acknowledgement. It means that if you present the results in your dissemination plan, you have to include the reference that you were using our systems. Don't worry about the confidentiality. There is a specific part also in the application, so you will share whatever you want to share. So if some parts of your project are confidential, they are confidential. And there is another detail about this larger scale and AI for science. If the project leader is an awardee of the European Innovation Council Accelerator Challenge, or has been awarded with EU-funded research projects, this part of the evaluation is skipped. Okay. What does that mean? That means, example, okay, I was awarded like a European project in 1992 while I was a postdoc on genetics, and now I'm applying for a partition for doing a large language model in Luxembourgish. This is not applicable, okay? The projects that are funded via EU or via European Innovation Council have to be related to the application, and they have to be recent. And for more practical advice, do some faux pas. Okay, so please pay attention to the eligibility criteria. I think I already said this, but it's really important. There are the rules. We cannot award you access to our systems if the eligibility criteria are not met. Regarding to industry, we're talking about companies. We need a valid identification number. So I'm thinking of doing a startup with maybe a postdoc or 2 colleagues. The startup is not yet official. You cannot apply. The good part about this, that the frequency of the cutoffs let you just wait to have all the documentation and the justifications in place, and then you can apply, okay? About the application, use the templates that we provide. It's really a pity having to administratively reject a project that is sound and that is interesting just because the applicant didn't use the template that we provide, okay? The team members, this is like common sense. If you are asking 5,000 GPU hours, it doesn't make sense that your team is like 35 people. There are not enough hours for them to use. So please try to design your team and get your team with the people who are actually doing the job, okay? Another recommendation, if it's your first time in any of our systems, you can apply or start applying for a playground or benchmark. These are limited resources, but you can familiarize with the partition, do your essays, testing, maybe porting, learn how the system works. And in fact, this is something that is not required, but highly recommended for the bigger resource calls, like the large scale and the AI for science, to have a previous experience in any of our systems or the system that you are applying, to actually know that the code can run there. Plan the resources carefully. This is about the range that I was talking in the beginning. Try to make a homogeneous usage throughout the award period. The technical assessment, they will provide you with advice and feedback, very useful regarding the resource usage. And regarding the project in general, take into consideration the Industrial Innovation Group feedback and the consolidated report feedback for your project. They provide valuable information, and they know how things work. So please listen to them, try to follow their indications. And last but not least, about good things to do is we are going to communicate quite frequently, so please always include the proposal ID. The hosting entity, the system in which you are running, they will probably give you an internal number of your project, but for us, the proposal ID and the project lead or principal investigator name is essential to locate your project. That will make our life much easier. And we want to actually go back to you as fast as possible, but if we have to kind of find your proposal across the thousands of proposals that we have, it's quite complicated. And again, common sense. For the calls that have a cutoff, do not wait to the last minute to do it. Technical things happen, so please plan in advance. And a good news, I guess, for applicants. This is just a brief stats of the total proposals submitted so far. The Industrial Innovation Access Mode is more recent. We started this year. Science and Collaborative EU projects call has been running for a little bit longer, but as you can see, the overall success rate is over the 60%. For Playground is much higher. So please, if you think that our resources could be interesting for your industrial activities, just apply, because chances are that you will get the access. And finally, about the next cutoffs, as I said, Playground and Fastlane are permanently open. Large scale has 2 cutoffs a month. These are the next dates, and the AI for Science happens every 2 months. So we have now at the end of this month in October, both large scale and AI for Science cutoff. As always, please pay attention to our website. There are regular updates. Both the calls, the dates may evolve with time because we are trying to optimize and improve the calls to the needs of our users. So there might be some updates along the way. So please always check our website for the latest information. And with that, this is the email that you can contact us with any questions that you have, and also the social media of the EuroHPC JU. Sorry, because when I'm sharing, I cannot see the questions or anything else, so I don't know if any made any question. Let me know. I will be happy to answer.
Thanks, Laura. There are questions coming in, and the team is handling them in parallel, so no worries for that. Can I just make a point that we will only pose questions which are useful, are general and are useful and informative for everybody. If you've got a specific question about a specific system or a specific call or an experience you've had, please could you contact us this directly. This is a webinar for general information, not for specific situations. I'd like to move on now to Mattis Buda. Mattis, are you there? Mattis will give us an update about the AI factory in Jülich, which will involve the Jupyter system, which, as you heard from colleagues earlier, is now operational and up and running. Mattis, are you there? Yes, I think
Yes,
you're there.
I think I am here.
Thank you very much. The floor is yours.
Good. Yeah, thanks, Joe, for a nice introduction. Also, thanks for Vangelis and Laura for the very nice and interesting first presentations. So I will now put the focus on Jupyter AI Factory, which was awarded in the second cutoff date. You should see here our overview slide, which already tells you a lot about the partners and everything what we are doing. So we have 4 core partners, all German entities like Forschungszentrum Jülich, RWTH Aachen, Fraunhofer, and Hessian AI. But now, since the announcement of the AI factory antennas, we are also very happy to welcome S Antenna Hungary and Belgium. And Belgium is also a little bit special here because Belgium is an antenna that is connected to multiple AI factories because they are also connected to Lumi. So this is kind of a very broad and strong ecosystem. And I will give you a little bit more ideas what we are doing and what is so special about Jive in the next 10 minutes. So you heard it in the first talks that AI factories actually, I think if we really put it very simple, they provide a large amount of computing power. They provide secure data rooms, also now with the discussed data labs that will come. And then they also provide AI development services, which is very important to actually bring ideas into operation. And what is really new, and we heard this also with the industry innovation track by Laura, is that it's not just for science as it was traditionally in EuroHPC, but it's also for companies. So we kind of extend the user group of what we're doing tremendously, going from science and academia also to professionals. Jupyter AI Factory, as you have heard, is one of the 19 AI factories that has been awarded so far, and we're very proud of that. We have currently the only exascale supercomputer until the French will put their system in place. So it's kind of the one with the largest compute facilities at the moment. So this is actually also what makes us in that kind of a little special. So as the name suggests, Jupyter AI Factory is basically built around the Jupyter supercomputer. This is not just great because it's such a strong and powerful system, but it's also good in terms of timeline. As you will see, you have heard that the inauguration took place, and I will discuss this in a minute. So it is Jupyter will be in operation very soonish. So as you have heard, it is in the build-up phase at the moment. So we can go into action very quickly and very soon, which is, I think, a big advantage of Jupyter AI factories compared to some other AI factories. We do not only have Jupyter, which is in fact our own EuroHPC system, but the partners and we also at Jülich, we have also multiple other systems, for example, Eureka DC, Jules, or the partners in Hessian, they have 42. So we have a bunch of supercomputers that we actually can also try already to use until Jupyter is in full operation and can be used as part of the AI factory. What we do, so in a nutshell, services is a crucial part along the data and the compute, but we see it, we do not only offer individual services, we also do that along the whole AI product cycle, but our aim is also to provide structural and systematic services that can then be applied and used by people, as you know, also as you have might have experienced from hyperscalers and others. So we really want to have an AI ecosystem that kind of is simple to use and functional and can be used at full scale of our full system. As Jupyter is so crucial for our AI factory, I would like to start a little bit discussing what Jupyter actually is. So you have here a picture of the inauguration that happens in September, so about a month ago. You see here, among others, the the Chancellor of Bundesrepublik Deutschland. In the middle, you have Friedrich Merz. And now we have a video, and I hope this goes.
Entering a new dimension of computing. Jupiter at 4 Central Units is Europe's first supercomputer to surpass 1 exaflops. That's 1 quintillion calculations per second, or a computing power of 1 million modern smartphones. To host this supercomputer of superlatives, a cutting-edge facility was built at the Jülich Supercomputing Center, the Modular Data Center. It was constructed in just 8 months, using 50 container modules. At Jupiter's core is the booster module from Evident. Its incredible computing power comes from 24,000 Grace Hopper superchips by NVIDIA, each one a mini supercomputer in itself, specially designed for scientific computing and AI. When training AI, Jupiter reaches over 40 exaflops, making it one of the most powerful AI supercomputers in the world. In practical terms, that's enough power to train a large foundation model with 100 billion parameters in just 1 week. Complementing the booster is the cluster module from Artec, the first system powered by processors developed in Europe. It's especially suited for complex data-intensive tasks. And Jupiter is more than a classic supercomputer. It's evolving into an AI platform through the Jupiter AI Factory. Its cloud infrastructure, Jarvis, opens up new possibilities to fine-tune pre-trained AI models and apply them to new tasks, a process known as inference. Massive compute power demands massive storage, and the data hall provides plenty of it. Modules are linked by a high-speed network, capable of transferring 3 times more data per second than the entire global internet. Another important factor is energy efficiency. Here too, Jupiter is setting new standards. Its first module calculates more efficiently than any other supercomputer in history. The secret lies in the combination of state-of-the-art processor hardware and a sophisticated water cooling system from Evident. The heat is dissipated through the rooftop directly into the ambient air. And that's not all. In the future, the waste heat will be reused to heat nearby buildings, another step towards sustainability. With Jupiter, a new era of computing has begun in Europe. A supercomputer with a modular architecture that's ready to integrate the technologies of tomorrow. With quantum computing and neuromorphic systems on the horizon, we're moving closer to solving challenges that are still considered unsolvable today. Together with Jupiter, we are shaping the future of computing in Europe.
Yeah, so much as an overview of Jupiter and also how it is kind of related to our AI factory. So some important highlights are summarized here again. So you've heard it. So it's an exascale system, which means traditionally it's more than an exaflop performance in double precision HPL. So a really practical application. We achieved this with less than 20 megawatt power consumption for an HPL. If not HPL is run, then obviously power consumption is even a little bit smaller. At the core, we have like the Grace Hopper 200 super chips. We have a total of 24,000 of them, and the network is a Dragonfly Plus topology, which enables basically using all of the 24,000 GPUs at once in either parallel simulations or in parallel AI trainings, which is also different, for example, to many of the industrial systems where you have like smaller islands that you can only use together. So here the focus was of making making or enabling to use all of the 24,000 GPUs together in single applications. We have a bunch of storage. It's a hierarchical system from an NVMe-based exaflash over spinning disk to tape. We have in total more than 1 exabyte. And as the movie also explained, we build everything in a modular data center to also make it flexible and extendable and to bring it into operation as quickly as possible. I said in the beginning, we have actually a very strong team, which is actually also providing the services in the AI factory to really bring ideas into reality. So we have obviously the people from Forschungszentrum Jülich, from Jülich Supercomputing Center, Mr. Lippert, Mrs. Mikkelsen. Then we have from RWTH, the head of the AI Center at RWTH, Holger Hoos. We have Hessian AI, which is actually a connection of all of the Hessian universities, and they also have a very strong established startup program. So we're very happy that they here the leader Christian Kessing is shown joined the project, and then we have especially focusing on transfer also to industry. We have 2 Fraunhofer institutes on board, led by Stefan Decker, the FIT, and Joachim Köhler, the EIS. You have heard this in the movie, and so Jupyter, let's say it's soon into operation, and then we can use this for 40 exaflops, for example, for training workflows. However, we are already thinking the next step, and in our opinion, the real next step in the field of AI, or what is a little bit missing at the moment, is like AI inference also for our users. So instead of building another big system for training, as other AI factories do, we build a system for inference, or an AI inference cloud. We call this Jarvis. That will hopefully come next year. And basically, the idea is that we then have a fully integrated into our ecosystem an AI inference cloud that is scalable, sovereign, and also features some European experimental technology. The software stack that we have, I mean, I don't go too much into detail here. It's very simple. So the training system is a classical, let's say, scheduler-based Slurm system, and AI inference cloud is actually an open stack with the Kubernetes. I just want to mention one thing. So we already have actually an inference platform running on our current cloud environment. We call it Blablador. It has increasing number of users, so we want to extend this also with the AI factory. Vangelis already mentioned these different application areas that are crucial to the AI factories, that are our application areas: healthcare, energy, climate change and environment, education, culture, media, public sector, finance and insurance, and manufacturing. There are 7 sectors that we want to deal with. However, we clearly say that our work is not limited to those sectors. So maybe we put a little bit more development work in those sectors, but at the end, also people who have applications outside are welcome, and everyone can use Jive. Yeah, well, back then, actually, Jive was, even before it was, it's before it really went into operation already. Ms. Virkkunen visited us and said, well, this is really the start now of the European AI, let's say, continent, and an important cornerstone. So we are very happy to participate and contribute to that. So with this, I want to conclude. So yeah, Jupyter is in fact the beginning of the exascale area in Europe. It is the first of already 2 planned exascale supercomputers that push computing to a new dimension. Jive basically is our vehicle to also extend Jupyter into an even more advanced AI platform. So not only great for training, but really featuring the full AI product cycle, from training to refinement learning to inference, embedded into a service structure. So this is what Jive is. And yeah, we really believe that the combination of HPC, especially HPC focusing of GPUs that we're doing in Jülich for more than 10 years now, the AI expertise, especially, I mean, we in Jülich have a lot, but we also have these strong partners, as I explained, exascale computing, and then the services that we have is kind of unique, and it's really one of the drivers of the European AI continent. And with this, if there are questions, I'm happy to answer. And otherwise, you also see here our contact information. we have the email address, we have the website. On the website, you can also we have also a contact form, or you can also request some services there. So please check this out, and if you have any questions and if you want to get in contact, then feel free to reach out. Thank you very much.
Thank you so much, Mathis. We are 8 minutes behind, so we're not doing too badly. So I'm going to pass the floor directly to Sasho Jureski, who is our AI factory in Slovenia. I think someone is presenting your slide, Sasho, and I'm going to suggest we keep going so that we have a bit of time for the Q&A at the end of the session. Sasho, you have the floor, if you're there. Are you there? No, he doesn't seem to be there. Is he there? No, he doesn't seem to be there. Okay, Rafael, are you there by any chance?
Yes, I am.
Do you mind jumping in so that we can keep going?
No problem, no problem.
I'm very grateful. So Rafael Assash, yes, merci, is from our AI factory in France, and she will give an update on what they're doing there. Thanks a lot to you, Rafael.
Thank you very much. I'm going to share my screen. Can you see my slides properly?
Yeah, I think you're good to go.
Perfect. Good morning, everybody. Thank you very much, Josephine and Mathis, for those presentations. My name is Rafael Assash. I'm the AI project manager for the AI Factory France that I will present to you. Now I'm very proud to start and showing us our logo. Our goal is to federate and highlight a very rich French AI ecosystem by bringing it together on a unified one-stop shop platform that is visible and accessible at the European level. So to begin, AI Factory France is coordinated by GENC, a French computing infrastructure that supports a wide range of research projects through 3 national supercomputers. On the left, you can see the Janzé supercomputer that is our current flagship infrastructure for AI research. It supports over 1,400 AI projects last year, thanks to 3,800 NVIDIA GPUs, meaning that overall, out of our 2,200 research projects, 60% of them are AI related. In the middle, we have our Ad Astra supercomputer that is tailored for both HPC and AI, and that relies on AMD technologies. And on the right, you can see our Joliot-Curie supercomputer that is mainly dedicated to HPC, and on which hosting site, the TGCC, that will host the future exascale supercomputer, so the second one in the EuroHPC network, Alice Lecoq, by the end of 2026. For the past 6 years, we have been meeting the AI needs, AI and HPC needs of our users, as shown on this slide with a wide range of application domains. And those people already have benefited from our computing resources. And you can see that it's the users range from startups, SMEs to large companies. So with that in mind, we proposed the AI Factory France project. So we are part of, obviously, of the network of AI factories. And as said earlier, that currently includes 19 AI factories and 13 AI antennas, which we will collaborate with, in particular with the Irish AI factory antenna. So yeah, we have to launch everything. Let me give you an overview of the project that is not officially begun yet. It will run over 3 years with a budget of 30.7 million euros, and it brings together a consortium of 20 partners from academia and innovation. So among them, we have long-standing partners, the Computing Center hosting our supercomputers here. We also have a strong network of French universities leading an AI training initiative called AI Cluster, along with partners that supports innovation for startups, SMEs, and large companies. And finally, LAMIAD, which is the ministerial agency for AI in defense. AI Factory France will provide shared access to computing resources, datasets, dedicated support, and training programs. The initiative will foster collaboration between academia and industry and startups, encourage the development of open source models, and promote skill developments. The goal is to establish strategic sovereign partnership with European cloud providers to foster collaboration between research and industry. And as you can see in this part of the slide, we aim to ensure a continuum between public and private services. And as of today, several companies have already expressed their interest in working with AI Factory France, either on industry-specific verticals, like Thales, or on strengthening the public-private continuum for computing resources, like Scaleway or OVH. A little bit more details on the services we aim to provide. Our goal is to rely on and strengthen existing services because as I said before, it's a very rich AI ecosystem in France. So those services include access to computing services, the availability to data space and models, providing expertise in HPC, AI, and data science with an expert network, training programs and a talent pool, and develop an ecosystem, for a startup with incubators and venture capital funds. Those services will primarily target 13 strategic sectors that you can see here, such as robotics, cyber defense, or material science. And we are aware that in the end, these verticals, like those applications domains, will probably not all reach the same maturity. However, some sectors are already very familiar with AI, such as healthcare and earth science. And to finish, I would like to highlight two examples of interesting use case. The first one is within the mobility application domain with a demonstrator for autonomous driving led by the company Valeo AI, along with the Public Research Center INRIA and the other NOAA-X. The objective of this demonstrator is to develop a release a generative world model for autonomous driving and to create a publicly available model, fostering transparency and collaboration in the field. Another use case in the mobility vertical is a demonstrator for mobility's impact analysis by the public entity EFPEN. The goal is to enable the daily quantification of mobility's footprint on the climate and the air quality by combining AI analytical capabilities with massive mobility data. Also, I would like to highlight the cyber defense vertical that is kind of we are one of the only AI factories that have this application domain. And our goal with LAMIAD, so the French Ministerial Agency for AI in Defense, is to focus on the cybersecurity of generative AI models, including the robustness against adversarial attacks and the detection of coordinated influence campaigns, among other activities. Thank you very much for listening. I hope it was clear enough. Don't hesitate to contact us to this address. You can also find the contact on our landing page, AI Factory France. Thank you very much.
Thank you so much, Raphaël. It was very clear, and very helpful. And thank you for stepping in.
No problem.
It was very much appreciated. We'll do Q&As at the end. Unless you've got a question, you can put one in the chat.
Okay.
And we can go from there. Sasha, are you with us now?
Yes, apologies for the technical issues. Teams
no worries.
died on me the second Jülich finished. So I hope that you can see the slides now.
I'm gonna blame it on the Jülich supercomputer video. Sasha, please.
Can you see the slides?
No, we've lost them again. If you'd like to share them again. No worries.
You can always share the slides on your side, and I'll just say next slide.
Okay, you start talking, and my colleague will share the slides. Max, are you there? Can you do that for us, please?
Okay, so my name is Sasha Dzerovski. I'm the technical coordinator of the Slovenian AI Factory. And I have to put in a disclaimer right away. I am not an HPC person. I'm actually coming from the AI side of things. And I would like to start with giving you a little bit of context for the Slovenian AI Factory. And that is that, one, Slovenia has a very strong AI community. AI research in Slovenia has started already in the mid-70s. Come on in, please. And now I'm having the head of the Austrian AI Factory visit, whom I had scheduled at the planned end of my presentation. So just give me a second.
No problem. They can join in as well if they wish. While we're waiting, Max, do we have the slide?
The EuroHPC update on AI factories. And just time for the presentation.
As you can see, everybody, this is live television.
Yeah, so we have Mario Drobic with us from the Austrian Institute of Technology. And if you manage to share the slides, it would be great.
Okay, they're coming up now.
Yeah, okay. I can see a screen. And I started telling you, fantastic, please go to the next. Yes, okay, great.
Thank you.
So yes, I was starting to tell you a little bit about the background. Slovenia really has a very strong AI community with research starting here in the mid-70s. And the strongest institutions here are the Jožef Stefan Institute, where I work, and also the University of Ljubljana, the Faculty of Computer Science. But we also have a very strong HPC community. You've all heard about Vega. You know about the Slovenian National Supercomputing Network, which also has a competence center on HPC. And what is certainly to emphasize, and it's not to be taken for granted at all, is that there is excellent collaboration between these two communities. And we capitalize on this within the Slovenian AI Factory. Next slide, please. Can you move to the next slide, please? Yeah, so in terms of infrastructure, and this is the slide on infrastructure, please. Slovenia already has extensive infrastructure. Vega is one of the very early EuroHPC systems. And I would like to emphasize that it has balanced architecture supporting both CPU and GPU workloads. And it is equipped with a data lake and excellent connectivity to already now support data analytics and AI. And we will be using this infrastructure before buying the new AI-optimized supercomputer. What is also important that in Slovenia, we have already established this broader view of infrastructure. In other words, it's not only the hardware that is the infrastructure. It is the data, it is the algorithms, it is the services. And so this view has already been established in Slovenia for a while. And in fact, the view that AI is infrastructure was emerging in Slovenia already before the AI factory concept was proposed. Already in early 2024, we had a local server at our institute that was serving a local instance of an LLM, in particular Mistral, both via a chat interface and API. And we also supported and still support fine-tuning of LLMs with data curated by colleagues at our institute. So in this context, we were very well positioned to join the AI Factory initiative. Next slide, please. And we have a very strong consortium for the Slovenian AI Factory, which includes the two research powerhouses that I mentioned, the Jožef Stefan Institute and the University of Ljubljana, and both of these actually have expertise in both HPC and AI. And it is really important for the smooth functioning of the factory. We then have infrastructure providers in the consortium. We have knowledge institutions, universities, and finally, we also have technology transfer organizations to make sure we actually reach industry and we get extensive use of the AI factory facilities by Slovenian industry. Next slide, please. And of course, we were planning and we are planning to build an AI optimized supercomputer, which will include both CPUs and GPUs. There will be the usual software stack supporting containerization and everything. And the location of this will be actually in Maribor, very close to a hydroelectric power plant. So in fact, we will be directly connected to this and not even go through the normal distribution network for electricity. Next slide, please. So the AI factory has, of course, a number of core work packages that I would like to emphasize here. The probably most important is building the core AI platform that will provide actually horizontal services. Then we will have a work package devoted to user-centric AI services, trying to build this, bring this closer to the end users through appropriate interfaces. And a very, very strong work package is the one on vertical services for sectorial applications, which will make the AI factory services accessible to the different sectors of Slovenian industry and society. Next slide, please. So the package on the core AI platform will be developing generic horizontal services. You will find here the things you expect, like AI workflows for training, fine-tuning, evaluation, and inference for large language models, but also visual language models, and in general, multimodal foundation models, but also things that are maybe not so common, like explainable machine learning and auto machine learning workflows, as well as workflows for automated scientific modeling, for example, of dynamical systems, which will include both simulation and machine learning, and will therefore be quite suitable for utilizing the mixed architecture of the AI optimized supercomputer. The other thing that I would like to emphasize here is that we will also have an online semantic catalog trying to make the data, models, workflows, and services overall fair, so that they are findable, accessible, interoperable, and reusable. And in this context, we are developing ontologies for describing these artifacts, and down the stream also annotating them so that we facilitate search and their reuse. Next slide, please. The next work package is dealing with user-centric AI services. Here, data storage connectors are important in the context of establishing and maintaining data spaces and making AI-ready data available within the SLIVE platform. An example will be remotely sensed data. There is strong interest in using such data in Slovenia, also interesting use cases, and we will be trying to support this as early as possible within the life cycle of the factory. And we will also have development of user interface and experience, and user engagement and feedback. Next slide, please. The probably largest work package of the whole Horizon Europe SLIVE project is the one on vertical services for sectorial applications. Slovenia is quite small, so we have actually many topics covered within this work package, starting with green transition, for example, agriculture, environment, energy, smart manufacturing. And here, for example, multimodal foundation models for remote sensing imagery are relevant. Also multimodal foundation models, let's say, in robotics, such as visual, language, and action models. Then we have in Slovenia quite strong, actually, health and biotech industry. in this context, diagnostics, personalized medicine, and drug discovery are relevant, and we will be looking, among other things, at foundation models for sensor data, for example, coming from wearables. Then we will cover also the segment of digital society. For example, as we speak, large language models for Slovene are being trained right now using the Vega and Leonardo infrastructure. This will be used also in the context of Gen AI for the creative or media sector, public administration, education, and so forth. And last, but certainly not least, quite strong vertical for us is AI for science. Slovenia is actually at the forefront of this very important, strategically important area, since we have expertise both in developing AI methods and using them in the different sciences, including life sciences, material science, environmental science, and of course, interdisciplinary research. And the areas like material sciences are also very, very important for industry. For example, materials are important in the energy sectors for the generation and storage of energy. So we have strong industrial interest in this area, even though at present we have put it here on the AI for science. Next slide, please. I would next like actually to show a couple of use cases very briefly. These are, of course, in the making, but should give you an idea of the kind of things that we will be able to support when everything is in place and running. The first use case is fine-tuning foundation models for the area of nutrition. Here we have a very strong group at our institute that has been carefully curating data in this area for a decade or two. And when we established this service within the institute to actually facilitate the fine-tuning of foundation models, they jumped at the opportunity, and we have been using fine-tuning of foundation models to address tasks like classification of recipes, whether this is healthy food, moderately healthy, or food to avoid, assessing recipe nutrient values. So you give the recipe and then you get the contents in terms of sugar, fat, unsaturated fats, and things like that. And finally, last but not least, making food data interoperable, so annotating recipes, abstracts with terms from ontologies related to food. This is in the context of making food data interoperable. So if you go on to the next slide, please, there is examples of data and prompts. Next slide, please, used for fine-tuning the Llama 3 model. And actually, on this slide, which is currently shown, you have shown the benefits of this fine-tuning. The yellow data are from Gemini. The red curves are for Llama, and the blue curve is for the fine-tuned model. And you can see that the fine-tuned model performs much, much better than these other models, because it's really exploited the curated data very, very efficiently. Another area, next slide, please. Another area we are looking at is actually materials design. We are exploiting here the fact that the Jožef Stefan Institute and also the Chemistry Institute in Slovenia have very strong material science research and also very strong connections to industry. So here we are using different kinds of data like parameters of material synthesis processes, quantum level properties of materials, morphology of materials in terms of images, to predict actually functional properties of materials like electrical conductivity, catalytic activity. For example, we are looking into catalysts for hydrolysis to decompose water into hydrogen and oxygen so that we get hydrogen for fuel cells. And the machine learning tasks that are addressed here is to predict the properties of materials from, for example, parameters of the synthesis process. And this, next slide, please. This allows us then to do a materials design. Once we learn predictive models that go from the synthesis parameters to the properties, then we can wrap an optimization process around this to actually find process synthesis parameters values to synthesize new materials. And the outcome of this process is that we get suggestions of new materials which can be synthesized and evaluated in terms of their properties. And we have been actually able to go through this process with domain scientists here at the Jožef Stefan Institute in a number of areas, and they have in fact really synthesized materials according to the suggestions of this combination of optimization and machine learning. And this combination of machine learning and optimization, it's important to emphasize again, is something that needs both CPUs and GPUs. For learning the predictive models, the GPUs come in handy, but then for the optimization process, it's actually the CPUs that would be handy. And I'm nearing the end of the presentation, so if you go to the final slide, please. What we have been working on very hard, even though we have been operational for only a month. Officially, we started September 1st. We are really working very much on developing the AI ecosystem, of course, primarily in Slovenia, but also broader. Here, I would like to emphasize our activities in the areas of AI for science. This has been identified as area of strategic interest for the EU. The European Strategy for AI in Science was just released last week on October 8th, and it will be officially launched at a policy event called the AI in Science Summit, which is taking place in Copenhagen on November 3 and 4. And I'm co-organizer of this event. We have also organized an event more on the scientific side, AI for Science conference here in Ljubljana. And this event also included an AI factories track. And I would like to thank the colleagues from the other AI factories that took part in this event and made it a real success. And last, but certainly not least, we are not only looking at AI for science, but of course broader for society, including industry and the public sector. And just in the last couple of weeks with colleagues here in Ljubljana, we have been reaching out to the Slovenian industry. For example, a colleague was presenting at the Slovenian Automotive Industry Conference. I myself was presenting at the conference on Slovenian robotics. And we are very pleased to say that there is clear interest and motivation in industry to be actually using the facilities of our AI factory when they become operational. And we are taking active steps to also shape this ecosystem. We'll be organizing an open industry day in November with the goal to better understand industry needs and appropriately plan the development of the Slovenian AI ecosystem, but of course, also specifically the services provided by our AI factory. And with that, I would like to thank you very much for your attention.
Sashil, thank you so much for that overview. It was very, very interesting. And now we'll let you get on with your other visitor. I'm going to pass the floor. Thank you. I'll pass on the floor to Andre. Andre is from Tilde Open. Tilde Open is one of the projects that has actually used our supercomputers, and he's going to tell you a little bit about his experience or their experience using our systems. Andre, the floor is yours. Do you have slides? Yes, you do. Okay.
Yes, I do.
There you go. Thanks a lot. Slides. Yes, we do. Thank you.
Yeah, thank you. Thank you very much for this invitation. So my name is Andre Sasilios. I am co-founder of AI and language technology company Tilde. And I, together with my colleague, Toms Bergmanis, who is a senior researcher and leader of this team, we will present our work on developing the foundational model for European languages, what was able, thanks to access to European EuroHPC infrastructure, to Lumi supercomputer computing resources. I will start with a few words about our company. We work on multilingual AI, enable diversity of European languages in AI world, and making sure that everybody in Europe can use AI technologies in their own language. We are based in Baltic countries, in capitals of Baltic countries, Riga, Vilnius, and Tallinn. And we are very much rooted in a European innovation ecosystem, participating in research innovation projects in Horizon and Digital Europe programs together with partners and academic sector partners. And that's thanks to our strong research team. We do have 9 PhDs and young researchers who really dig into the roots and state-of-the-art approaches in AI, in large language models. And we see fantastic benefits what recent developments with large language models can open. They really that's really a breakthrough in the potential what AI can do for language-specific tasks, for extracting knowledge out of tons of information in written and spoken languages. But the problem is that most of the current AI models, what are used by millions of people, are English-centric, because they are trained on all the data what's available, and most of the data globally produced is in English. And what we do see that in the most popular models, like GPT models, more than 90% of training data used is in English. And then for other languages, only 10% remains. And for my mother tongue, Latvian, 2 million speakers, it's a minuscule part of training data in these models, but AI is as important for Latvians as it's for English or French-speaking people. So this is why we want to address this problem. The problem that current models lack cultural depth, context, quality that's needed for applications. And we did some also formal analysis assessing error rates in these models, and we do see a lot of wrong lexical choices, invented words, broken syntax, and other grammatical issues in these models. So how to address this? And our ambition was what we need to develop open multilingual AI model for European languages, what treat all Europeans as equal citizens in the AI world, and all the European languages are first-class languages. And for that, 3 ingredients are critical: know-how, how to do that, data, and computing resources. And thanks to our fantastic research team, we do have deep understanding how to do that of the most recent approaches and algorithms and ways how to address this language gap. For data, we do participate in European data infrastructure activities, like we are one of the core members in language data space infrastructure development. This is one of the part of the European data space infrastructure that opens tons of data from public and industry, what is essential for model training. And then missing component was computing power. And so we applied to AI Boost large AI grant challenge. That's a challenge like initiated by European Commission with support of EuroHPC, organized by AI Boost Consortium. So that was a big challenge to identify most innovative companies and give them access to computing resources. And we were so happy to be selected as a winner of this competition. And to be able to use 2 million GPU hours on a Lumi supercomputer based in Finland, with ambition to create foundational model with 30 billion parameters. That's really a large model for European languages, and make it fully open, fully available for all kind of academic or industry work, whoever can benefit from this. And One particular aspect what was important in our work is that we had to make sure that it's transparent with data what's used, and we make sure that it's not infected with disinformation. And some recent reports and studies show that popular global models are really infected by targeted disinformation campaigns by Kremlin. Feeding web with disinformation sources, what eventually went into model training. So we cooperated with centers that study these effects and created a special filters and approach how to make sure that these models are free from propaganda, are really minimize any bias and toxicity of the content, and to align to the EU AI Act requirements and guidelines. Now I will pass the floor to my colleague Toms to dig into more about details of developing this model.
Yeah, hi. So the ambition was to create this relatively large model, and that of course also requires processing quite a lot of data, requires also quite a lot of compute. So one of the challenges, not only for us, but for everybody who actually is undertaking such a large scale optimization task, is to get these models that we usually have working on the relatively small setups to multi-node, multi-GPU setups in a distributed fashion. So I think we were quite successful at that, as our setup with 768 GPUs was relatively high efficiency, and we managed to train them. We used roughly like 1.5 million hours to train the first iteration of the base model, and that was within roughly 2 months of compute time, which translated to 3 calendar months, because there are like often some waiting times that you have to plan into when you're working on HPC environments. Again, it was close work with experts in Lumi, and also some consultations with colleagues from AMD, because there are some things you need to take into account when migrating from NVIDIA environments to AMD-based supercomputers to make it possible. Nevertheless, yeah, like our achieved throughput on this system was excellent, and we are still working on extending, making even still improving the model using Lumi supercomputer resources. So in general, a bit more about next slide, please. So a bit more about our mission. So Andres said several things. Some of them might sound like political statements, but all of them are actually quite practical. For example, when we talk about language equity or equal representation of languages, we actually mean that the model is very efficient for languages like Ukrainian, Latvian, or Polish, just as it's efficient for English and French. That means that the tokenizer has to be very efficient, so that the underlying compute is used efficiently as possible. Next slide. So one other thing that we actually did very differently than other large language models that are European or American or Chinese is that we showed relatively little data from very large languages and relatively a lot data from small languages. So we organized this training in 3 stages, which meant that at the initial stages and the last stages of the training, model sees predominantly all languages uniformly equally, meaning that Albanian and English is seen is shown to the model equally frequently. That results in very good results in natural language understanding and generation for all languages. While the middle phase, where we showed more data from larger languages, ensure that the model benefits from the knowledge found on the documents of these languages. Next slide, please. The resulting model is more efficient at or better at language modeling than others equally sized European and American language models for all language families that we covered. Next slide. And this results in a model being better at identifying grammatically wrong sentences or avoiding grammar mistakes in text. Next slide. We also tested on European exams. Those are the exams that pupils are taking at school, as opposed to what people usually test on, which are American exams translated into European languages. And then we also see that our model, having seen these small languages equally frequently with other languages, is actually very good at understanding the questions out of the box and does very well on all the languages that we tested. Next slide. And then from kind of already practical tasks and applications, we also test adapt model for translation. And there we see that, for example, in German, in a task of translating from German to all other languages, model is already approaching the level of ChatGPT 4.1, which is a 60 times larger model. So the results are very good for such a small model. Yeah.
Thank you. And yeah, the work on this model still continues, and we continue to improve it. But we already see that these evaluation results are very good, and we believe that this model can truly serve as a foundation for sovereign European multilingual AI ecosystem. And yeah, because it's open weight model, fully free to any further development, fine-tuning, adaptation work, you can develop applications based on it for public sector, for academic research, for industry applications. We at Tilde work on tasks like language translation, question answering, summarization of text, and adapting to particular industries and public sector users. These applications can also be used in media or in the sectors where privacy and security are of essential concerns. Because this model could be deployed locally in the infrastructure of a particular organization, making sure that no data is leaving out. And to make it even more affordable, now we want to work on distillation of this model and pruning to make it even more compact, so it can run cheaper on less demanding infrastructure. And our future plans, we are very happy for this opportunity to use EuroHPC infrastructure, Lumi supercomputer. Otherwise, it was not impossible to develop this model. And we want to continue to utilize these opportunities to work on sovereign European AI solutions so that we can enjoy European-born, European-developed, open, trustworthy, inclusive AI models. And in particular, we are part of early access adaptation program at Jupyter. You heard this fantastic new exascale infrastructure, and we closely collaborate testing, trialing, and exploiting it. We participate in Latvia AI Factory Antenna project, helping other players here to learn and use these HPC infrastructures. And we will be happy to continue to apply to EuroHPC resources for specialized AI models for public sector and institutions. So thank you very much.
This is brilliant because we're still only 7 minutes late. So thank you very much for going so quickly, and thank you very much for presenting the project, which again sounds very, very interesting and will have interesting implications for all European languages. So grateful for that. We've now come to the end of the presentation session of this webinar, and it's now an opportunity to ask more questions. We're going to ask you to put your Q&A again in the chat, and while you do that, I'm going to read a couple of the questions that came up throughout the morning and then get some of the colleagues to answer the questions. I'm going to start with one related to what scientists, what researchers can get out, what kind of course the researchers can apply for, because I think that's something that maybe some of you don't realize, and that's the simple fact that researchers could always get access to our supercomputers. But maybe, Laura, can you just give a little update, or Clara, if you're there, on what researchers, how can they get fast access to our supercomputers?
Myself? Yeah, we have several access calls going on. They are still going. It's true that today we center more on the industrial kind of users, but researchers, you can apply to the AI for Science, for example, in the ones that we were covering today, and also Vangelis mentioned some more traditional HPC calls, the benchmark, development, regular, and extreme access. All the information is on the webpage. If you want to make like a specific question about this, maybe you can put it in the Q&A and I can explain further.
Okay, thank you for that. Then we had another question about what's coming up next after AI factories and gigafactories, and what's going on with gigafactories. And as my colleague Vangelis has already answered in the chat, I can just say that gigafactories will be the next generation of procurements and services that the JU is supposedly going to be managing. However, we don't have much information yet about it because this is still subject to discussion between the member states and the European Commission. But to generally say, as Vangelis has already put in the chat, all member states will be able to apply for gigafactory if they wish to do so. And then in terms of what's happening on the third, as we call the third cut of AI factories and the 13 new antennas, yes, Cyprus has an antenna. They were awarded an antenna last week, and so the 13 countries will be signing grant agreements and then setting up their antennas in the next few months. We have 2 new questions. I can't see them, colleagues. Okay, here we go. Yes, I can see them now. Selma, you ask what is exactly a collaborative EU project? We've actually answered it, but I mean, I think maybe, Lara, do you want to tackle that one again?
Yes, we are referring to EU-funded projects that provide enough proof that they are either ongoing or recently granted. So this type of projects that require resources, they can apply to our calls to kind of cover that resources that they are planning to use in that project.
Okay.
Let me know.
Thank you. That's great. And then Ana Garcia Robles, who's actually from our private members. Hi, Ana. Her question is, if an AI company wants to use an AI factory services, does it need to go through the EuroHPC access point to request hardware resources, or should it go directly to the specific AI factory for this activity? How is this coordinated? So colleagues, who would like to take that one on? Vangelis? Well, Lara, you look like you're ready to talk.
I mean, some of the AI factors are still in the process of settling, let's say. So let's say that like the calls, the access calls go through our peer review office. So either way, if you're coming from the AI factory, the destination is our office. So as you want, because some of the AI factories still don't have like the web page or anything set in place to actually do directly that to that. So it's better for now to just contact us directly. It will be faster, I guess.
Exactly. So to build on that, if you're interested in a particular AI factory or a particular AI antenna in a country near you, and you're not sure how to contact them, go to our portal, and we will then write your question. We will then coordinate it with the local country, who can then contact you directly. You can also, of course, contact them directly. I see Mattis has got his hand up. Do you want to answer this question?
Yes, I mean, I fully agree that always going through EuroHPC portal is a good step, but I just wanted to also clarify that I think sometimes, especially in this beginning phase, it might be actually not too bad to also contact, for example, us in Jülich directly, because as you know, Jupiter is not in operation. It's officially our only EuroHPC system. So it is very hard for the colleagues from EuroHPC to actually give you at the moment compute in Jülich because there is no running EuroHPC systems. However, we have the other systems that we maybe can help you with, but this obviously won't go through EuroHPC. So I think it's always good to try to reach out on both sides. It also depends. So we also see a lot of requests where people actually do not need a lot of compute, but it's more about services and other things. And always going through EuroHPC can help, but I mean, there are often also very simple solutions that can be simpler implemented if you just contact us directly. I think it's a case-to-case dependent thing that we have to still establish or find a good balance. But I just want to raise the point that there are also good other contact opportunities.
So the question was about coordination, Matty. So the point is that the JU will coordinate if you contact us, but of course you can go directly to the relevant country as well. Okay, thank you for that. What else can we answer? I'm just looking at the questions here. Can we share more about data labs and AI factories connection to data spaces? Is this already ongoing? What are the modalities? So yes, it is ongoing. We're still working that one out, depending on the different situations. But again, if you've got a specific question related to one particular factory and their connection to the different data spaces, same point. You can contact us, and we will establish the connection with the relevant factory or supercomputing center, or answer you directly. But this is still ongoing, and it's not, the connection as such has not been done yet. It is something that is, it is ongoing. Another thing, just bear in mind, we are answering the questions in the chat if you want more information on that. Okay, what else? A freelancer doesn't have a VAT, could they access the AI factory resources? And the answer has been yes. No, you can't. You need a valid VAT number for that purpose. Okay. All right. Any other questions, colleagues, that you see that you'd want to answer? Maybe. And also this applies to our speakers, if you see anything you want to answer. No, are we good? Okay, good. So just to sort of conclude, the recording and the slides will appear on our website. So if you want to go back and have a little bit more look at the detail of what we've said, it will all be there. Also, if you're interested in accessing our systems, and you want to understand a little bit more about it, you can also look on our website for access policy and our portal. There's a lot of information, Q&As about the hows, the whats, and the wheres of how to access our systems. If you want an update on want to contact a specific AI factory or an antenna, again, our website, we have a portal dedicated to that. And yes, to a point that was made in the chat earlier, we still need to update the different services that the new factories and antennas will be providing. That's work in progress, but as we already described, the factories and antennas were only literally announced last Friday. So we're still in the process of contacting them and making and updating that information. So my message to you is keep watching our website. It will be coming, and it will be coming soon. And last but not least, on the gigafactories, if you're interested in that, then I would follow what the Commission is doing in that realm, and hopefully we'll have more news on the implications of what gigafactories will mean for the JU and what we will be doing probably at the end of the year. Okay. I'm just looking at my colleagues just to see. Yeah, I think that concludes our webinar. I'd like to thank everybody who spoke for this very fast action-packed morning. And I would like to thank all the participants who joined. I think the top number was about just under 200 people, so that's a bit of a record for us. So thank you for all joining. And as I said, if you have got specific questions, you can contact and reach us again through the website at EuroHPC. So on that note, thank you very much, and I wish you all a very nice Friday, and when you get there, a very nice weekend. All the best.